You notice we start off with a whole bunch of identities here, okay? And really, chapter 5 is learning a whole bunch of trig identities. So as we go through, I mean, you've got this section here, we'll learn trig identities in probably almost every lesson we do, okay? So we're going to be constantly adding to this list. At the end of the chapter, I will provide you a list, so it's not that you'll have to have them memorized. But the more you use them, the more the more you will become familiar with them. Okay? So let's look at these, and then we're going to practice learning how to use them. Okay? And so we have, 5 different sets of identities here we're going to talk about. Some of these should be familiar to you. Reciprocal identities. Now, it may look funny that cosecant of theta equals 1 over sine theta, but what do you know about cosecant and sine? Cosecant and sine, you should have known before today that they are reciprocals, yes? So if cosecant and sine pair up and they are reciprocals, the fancy way of showing that is that cosecant is equal to 1 over sine, or sine is equal to 1 over cosecant. That's a fancy way of showing it. Just knowing that they're reciprocals, though, does the same job. You'll see that cosine and secant pair up, and tangent cotangent pair up as well. Quotient identities. We've talked about these a little bit, not by name, but have we talked about the fact that tangent is equal to sine over cosine? And cotangent is equal to cosine over sine? We've talked about those a little bit, haven't we? So those are our quotient identities. Okay? Now, new to us are going to be Pythagorean identities. These are going to be super important, and we're going to use them a lot. Okay, you'll become very familiar with them. But these are 3 Pythagorean identities. Sine squared of theta plus cosine squared of theta equals 1. That is probably the most common one that you'll see us use the most. And the idea with that one, if theta could be any angle, okay, if theta is some angle, and you plug it into sine and square it, plus plug it into cosine and square it, it will always equal 1, no matter what the angle is, as long as it's the same angle plugged in both places. We're going to use it more as a relationship, though. Okay, so there's that one. There's 2 others. 1 plus tangent squared equals secant squared, and 1 plus cotangent squared theta, equals cosecant squared theta. And then we have 2 other lists here. Cofunction identities. Now, you'll notice that they pair up the reciprocals again. Sine of pi over 2 minus theta equals cosine of theta. Now, let me pause for a moment. Pi over 2. What is pi over 2 equal to in degrees? What? 90? Yes? If you go back and convert it, or if you go back to your unit circle, I know it's been a couple of weeks since we've worked with those, but okay, so just kind of a reminder, pi over 2 is equal to 90 degrees. So these just as easily could say sine of 90 degrees minus theta equals cosine. This just represents that they are basically just phase shifts of each other. Cosine and sine are the same graph, just shifted over, right? They're both that up-down curve. Tangent and cotangent, shifted versions of each other depending on reflections. And secant and cosecant, shifted versions of each other. And then we also have even odd identities. Okay, we talked about even and odd functions sometime in first semester. I don't know if you remember that or not, but we did. Because we talked about even functions being functions that are symmetric across the y-axis. And we talked about odd functions being functions that are symmetric across the origin. Okay? And so the idea that if they're symmetric across the origin, which is going to be sine, tangent, cotangent, and cosecant, if there's a negative put in there, it's equal to a negative. Okay? Cosine and secant are going to be the 2 that are even. And when they're even and they reflect across the y-axis, then they're just going to be equal to the positive. But basically, your even odd identities say, okay, if there's a negative in my with my angle, how can I pull it out? Does that negative get pulled out and make my function negative, Or does that negative get pulled out and make my function a positive? And that's what I'll end up doing. Okay, so these are ones to be familiar with. We'll reference them and use them quite a bit. Now, key point before we start some examples. The idea with these identities is that trig functions can be replaced with other equations that they are equivalent to in order to simplify or solve. So we're going to use these to switch pieces in and out to find what we want. Okay? So let's look at example 1 together. Notice it asked me to find sine theta and cosine theta, given that tangent of theta is equal to 5 and cosine of theta is less than 0 by using the identity. So the identity's up top rather than reference triangles. So truth, I could give you this exact same question back in chapter 4. And we could have done this with SOHCAHTOA. Okay? But we're trying to think about this differently here. And so we're going to use these identities up above. So, given tangent, we need to find sine and cosine. And I'll pretty much tell you, we're going to need to use a Pythagorean identity to start with. Okay. I don't know if anyone was kind of peeking up top to see if they could figure out where to start or not. Did anyone spy the quotient identities and think we might go that direction? Because it would make sense if you did. Okay. But here's what I'm going to tell you. Just knowing tangent is 5 does not mean I know sine and cosine. Knowing tangent is 5 means I know the ratio between sine and cosine is 5. But in order to use one of those quotient identities, you would have to know at least 2 of the 3. So out of like sine, cosine, tangent, you would have to know 2 of those 3. And we don't right now. So we're going to pick a Pythagorean identity. What Pythagorean identity could we use? What do we know? What? Yeah. If we know that tangent is 5, could we use the Pythagorean identity that is 1 plus tangent squared equals secant squared? Yeah. So I'm going to actually reverse that since I'm going to end up trying to find secant. I'm going to write this as secant squared theta equals 1 plus tangent squared theta. Now, what do we know that we can fill into this identity? We know that tangent is 5, yes? Which, okay, pause for a moment. I think I've already talked about this year, but do you guys realize it says tangent squared theta? Have we talked about the fact that that is the same thing as saying tangent theta quantity squared? That's all that's saying. Okay? So just, it's a way you can write it without the parentheses. Okay, so we know that tangent is equal to 5. That means I'm going to plug in 5 for the value of tangent. So I'm going to rewrite this. A secant squared theta equals 1 plus, now if it's tangent squared theta, that means what am I going to do? We're going to put 5 in for tangent and square it. Okay. Can you do a little cleanup there?
When you plug the 5 into tangent, you just get rid of the middle.
Right, because tangent theta is replaced with 5. That theta is part of the tangent. We don't know theta, but we know that tangent of whatever theta is equal to 5. Okay, so yeah, the theta will be gone. What do we know about 1 plus 5 squared? It's 26, correct? So I now have the statement that secant squared theta is equal to 26. Okay. Math skills. How do we solve? What?
Square
square root. If this is secant squared theta equals 26, let's try and find secant theta, which means we're going to take the square root. If I square root one side, I square root the other side. The square root of secant squared theta is just going to be secant theta. What about the square root of 26? No. I'm laughing because my morning class someone made the exact same mistake. And I was so confused at what she did this morning until she commented, 26 is not 4 times 6.
Oh, that's right.
Yep. As I said, the same exact thing happened this morning. So.
Just leave it.
Okay, just leave it. What else do we want to put with it?
Plus or minus.
Plus or minus? Did we take the square root in an equation setting?
Yes.
Yes. So we need to say that secant theta is equal to plus or minus the square root of 26. Now, it can't be both. It's one or the other. Is it positive or is it negative? Why? I need a positive or negative answer with a reason. My hint is to go back to the original given information.
Negative because tangent divided with cosine theta. Would you use the all students?
Would that, I guess that would work. I had an easier direction to go with it. Or in my mind, I see where you're going with that.
Opposite of this.
Well, but we don't know for sure which quadrant tangent is in. It could be in all or the tangent quadrant.
But we know the cosine.
Okay, and that's what, okay, I didn't catch you had said that. Cosine less than 0, what is that telling me? We know that is fancy speak for cosine is negative, yes? So, Tate took us the quadrant direction. If tangent's positive and cosine's negative, that puts us in quadrant 3. I agree. I have a technically slightly easier route, I think. What's the relationship between cosine and secant? The reciprocals, yes? So if cosine's negative, what do you know about secant? It's negative. Okay, so the same reasoning goes into play. But if cosine's negative, then secant has to be negative. So we are going to say that secant of theta is equal to the negative square root of 26. Okay, are you with me? And as you know, when we mentioned the quadrants, that would be agreeable too. Now, all of this work, and I technically have not found an answer yet. What were we asked to find? Sine and cosine. All I have found so far is secant. Thoughts? Yeah. If we know secant, what do we also know?
Cosine.
If we know cosine, because they are reciprocals. Now, you can just take the reciprocal and tell me what cosine is. Or, if I want to be official, I can write it out as cosine of theta is equal to 1 over secant theta. This is the official way to write it. But again, it's just the reciprocal. If we look at this, cosine of theta is going to be 1 divided by, what is secant? Negative square root of 26. And so that gives us the statement that cosine is equal to the negative of 1 over square root of 26. And now we've at least found one answer. Now, we still have another answer to go. I am going to tell you up front, this is not, there are different ways you could do this. Not everyone's going to take the same path. We all need to use the identities, but there's different ways you could get there using identities, okay? So just kind of be aware. As you go to help each other and check with each other and stuff, there are different routes to get there. Now, I technically have one more piece to do this, yes? And I definitely have two different ways I could go with this one. I mean, at this point, we were given tangent, we found secant, we found cosine. I need to find sine. Take a peek up in the identities. What options do you see? Okay. Could we use a quotient identity now? Do I know two of the three? Yes, I know tangent and cosine. So could I use that to find sine? We can, and that's going to be my recommendation of where we go, is that we write down the quotient identity. Tangent of theta is equal to sine of theta over cosine of theta. Fill in what you know. Tangent is what? 5. Sine of theta is what I'm trying to find. Cosine of theta is -1 over the square root of 26. Okay. Think algebra. How do we solve that equation? Right? We're trying to find sine, yes? We're trying to find sine of theta. If it's sine of theta divided by something, we're going to multiply by something. So we're going to multiply by -1 over square root of 26. So that means sine of theta is going to be equal to whatever 5 times -1 over square root of 26 is equal to. And again, we're not using the calculators right now. What is 5 times -1 over square root of 26? Yep, multiply together as one fraction. Think of this as 5 over 1. So -5 over square root of 26. Okay. You guys saw quotient identity and went for it. And that was going to be my recommendation. Okay. Technically, the side note, just throwing it out there for you. Okay. At this point, we knew cosine and we needed to find sine. Another option could have been using a different Pythagorean identity. We could have used the Pythagorean identity of sine squared plus cosine squared equals 1. Because if you know cosine, you're trying to find sine, we could have done that just as well. And you would have gotten the same answer, so it doesn't make it wrong or anything. So this is where I say there are different routes to get to these answers. But I need you using the identities, okay? Don't go back to chapter 4 methods. Okay, questions there? Okay. We'll get to practice that process again with example 3, but we're going to do something slightly different in example 2. Given that cosine of theta equals 34/100ths, find sine of theta minus pi over 2. First of all, you'll notice some whiteout on this page. Yeah, I goofed, okay? I had typed these up last week. I had copied them on Friday before I left. I was working on my new answer key last night and realized that I'd made a typo. So I went through this morning and whited out and rewrote. Okay. Thoughts? We're given cosine, and we're trying to find sine of theta minus pi over 2. What do you notice in terms of identities? Scan your identity page. No? This,
Co-function.
okay. Does this remind you of a cofunction identity? Is it exactly a cofunction identity? What's the cofunction identity say? The cofunction identity says the sine of pi over 2 minus theta equals cosine.
Trace Bowers, Gage Kendall, and Drake Mackey in the high school office. Thank you.
Okay. So your official cofunction identity from the top half of your page reads this, yes? Sine of pi over 2 minus theta equals cosine theta. Is that exactly what we have here in the sine area? It's close, but not quite. Yes? Okay. So here's what I'm going to ask that we do. Let's do a little reorganization, if you will. Okay. If we look at what we're given here, we're given that theta, we're given theta minus pi over 2, yes? But what order is the cofunction? It is in the backwards order, right? So what is this theta minus pi over 2? What does it look like when I flip the order here? It is what? It is negative pi over 2 and plus theta, correct? Now, it's still not exactly though, is it? What is it different by? It's different by a sign, right? So if you think of it as factoring out a negative, if you factor out a negative, it's the negative of pi over 2 minus theta. Theta minus pi over 2 is equal to negative of pi over 2 minus theta. Agree? The reason I did that is that makes the connection between the cofunction of pi over 2 minus theta and the problem we have, which is theta minus pi over 2. Okay, that's the only little trick to this problem. So, okay, they want us to find the sine of theta minus pi over 2. So we're going to work the steps. What did we just say theta minus pi over 2 is equivalent to? I can take this and replace it with this, correct? So now I'm going to rewrite this as the sine of the negative of pi over 2 minus theta. Now, I use some parentheses there to be official. Now, there's a factor of negative, yes? Can I just pull it out front and put it out front of the sign? Kind of. What does your even-odd identity say about sine? So look back up the top of your page. What does your even-odd identity say about sine? If there is a negative on the variable, what is it on the inside? What does it say? It is a negative on the outside. So can we use that fact? This negative on the inside can become a negative on the outside. So I'm going to rewrite this as the negative of sine of pi over 2 minus theta. Okay. Now, ignore the negative for a moment. What do we know about sine of pi over 2 minus theta? Sine of pi over 2 minus theta, according to our cofunction identities, is equal to cosine. So what can I replace it with? I can replace it with cosine. Now, what about that negative out front? That negative out front is just going to carry down. So negative out front carries down. The sine of pi over 2 minus theta turns into cosine theta. What do we know about cosine theta? What do we know about cosine theta? It's equal to what? 0.34. So what do we know negative cosine theta is going to be equal to? Negative 0.34. Now we're just carrying that negative down again. It's going to be equal to negative 0.34. Okay. It's all exercises in the connections of the identities. And I know this one is easy to see, but yet also challenging to see. Okay. I know I did several steps here trying to prove the connection. But, generally, pi over 2 minus theta is just backwards, right? It's backwards by a negative. Since sine of pi over 2 minus theta is equal to cosine, then sine of theta minus pi over 2 was the negative cosine. Okay? It's learning how to use the identities. I think we see one like this, at least one like this in homework. Okay? Look for when you see something with a pi over 2 minus theta or theta minus pi over 2. Think cofunction identities and try and make it work. Okay. Example 3. Now, you probably, I don't know, I'm guessing at this point you maybe liked example 1 better than example 2. Example 3 is like example 1. Now, there are multiple different ways we can go here. So it kind of depends on what we see and what we discuss and want to do. But on this particular problem, we're being asked to find secant theta and cotangent theta, given that sine of theta is negative 2/3 and tangent of theta is greater than 0. And, whatever we end up doing, it's not necessarily right or wrong. It's just a matter of what we see. Thoughts of directions I could go. Peer into your identities and look for connections based on what we know, what we could find, what we have to find in the end. Okay. Which Pythagorean identity do you want to start with? Okay. So one option, and the more obvious option for the moment, is we're given sine. So sine squared plus cosine squared equals 1, yes? And that's one option to go with. Now, what if I point out the fact, what is that going to find for us? It's going to find cosine. Is that something we have to have? No. Okay, because we're asked to find secant cotangent. What? Okay, so one option. And again, I'm just trying to get us to look at options. Okay, so one option is we can use sine squared plus cosine squared. That would find cosine squared, and then we can find the reciprocal of that. Yes? Now, I'm going to point out an option going the other way. And again, it's not right versus wrong. The other option is, what if we flip sine from the beginning? What does flipping sine at the beginning give us? It gives us cosecant. What Pythagorean identity could we use cosecant with?
Cotangent.
Cotangent. So then that would find us cotangent. Again, it's not right versus wrong. Understood? Okay. They're both good. They both get us places. What do I want to do with you guys? I think I'm going to go the way of the cosecant cotangent way. In all honesty, if you feel confident enough, you could try it and go the other way. Okay. So if I go the way of the reciprocal or the cosecant option, we know that sine is the reciprocal of cosecant, yes? So I'm going to write that cosecant theta is 1 over sine theta. And again, I don't care if you don't write the reciprocal identities out like this. It's a little overkill once you understand. So cosecant theta is 1 divided by what was sine theta? Negative 2/3. What is 1 divided by negative 2/3? Okay. 1 divided by negative 2/3 becomes 1 times what? Negative 3/2. In other words, 1 divided by negative 2/3 is negative 3/2. It's the reciprocal, yes? It's a fancy way of getting to the reciprocal. So now since I know cosecant, could we use the Pythagorean identity with cosecant and cotangent? Yeah. 1 plus cotangent squared theta is equal to cosecant squared theta. Plug in what you know. 1 plus cotangent squared theta is equal to, how do I do cosecant squared theta? Means I'm going to do negative 3/2 and square it. What is negative 3/2 quantity squared? What do you say back there? How do you square 3/2? 3/2 times 3/2.
6.
Check your math. 9 over 4. Negative 3/2 times negative 3/2 is going to be positive 9/4. So 1 plus cotangent squared theta equals 9/4. How do you solve the equation? If we're trying to solve for cotangent, we're going to do what? Subtract 1, yes? How do I subtract 1 from 9/4? What is 1 in terms of fourths? 4/4? So in order to do 9/4 minus 1, you're going to be doing 9/4 minus 4/4? So cotangent squared theta is going to be equal to 5/4. What's the next step we take? Square root. So then we're going to have cotangent theta is equal to what? What do I need to put in front? Plus or minus the square root of 5/4 for the moment. Now, why is Aiden saying plus?
Tangent and sine of both cotangent.
Okay. All that really matters here, if tangent is positive, what do we know about its reciprocal? It's positive. Okay. So right there, that will carry down. What about square root of 5/4? How about half stays the same? Square root of 5 is square root of 5. What's the square root of 4? So how could I rewrite this? Positive square root of 5 over 2. So that is cotangent is the positive square root of 2 over, or square root of 5 over 2. Now, I'm probably about out of time. What do we still need to find?
Secant.
Secant. Okay, so tomorrow you have to tell me how to find secant. Awkward place to stop, but it is what it is. So tomorrow we'll work on that. We'll work on the back side. Folks, this lesson is going to take practice. That's all I can say. Okay? Me leading you through it and you doing it on your own are two different things. So that's why you'll see that first assignment you'll be working on tomorrow is the odds. Because I want you to have answers to check. You know, it's going to take practice. Okay? So we'll work on this tomorrow.